So we're about to look at the January 2024 exam. Are you ready? Well, first, before we get started, let's have a peek at the scoring conversion chart. Okay, so again, here is the 65%. You can see again in January, same as in August, you needed 51. So typically 50 is the mark, but could be a little higher. Rarely a little lower, but about 50, 51 typically. And then if we look, in order to get an 85, you needed 75 points. Again, that is an increase of more than 20 points. Why? A couple 68s, a couple 66s, a couple 73s, and so on. Okay. Again, also notice this. 264s, 263s, 261s. So to get from 60 to 65, way more than 5 points. Okay, so again, on the multiple choice, we're aiming in our mind 40 or higher correct. 35 is acceptable toward getting you to that passing grade, but we're aiming for 40 or higher. All right, January 2024 exam time. We're going to start with Part A. Part A are the easiest multiple choice questions. Don't involve a lot of steps. Should be fairly straightforward. Okay. Which particles surround the nucleus of a neon atom? So if we're looking at an atom, what do we have in the center? We have a nucleus, and then we have electrons in orbitals, right, in energy levels surrounding the nucleus. So which particles are found outside or surrounding the nucleus? Yeah, that's electrons. Which conclusion was proposed as a result of an experiment during which some alpha particles were deflected while passing through a thin sheet of gold foil? So the gold foil experiment, what did that do? Well, since most of the alpha particles literally went through, okay, it determined that the atom was mostly empty space, right? But this is asking about why were some deflected? Well, some were deflected because what did they bump into? They bumped into a small but dense, positively charged nucleus. Number 3, the mass of each proton and each neutron is approximately equal to. Well, for this one, there is a reference table that I can use for help, and that is Table O. Okay, so it was asking me about proton and neutron, right? So if we look at Table O, proton and neutron, what do they have the same? They have the same, this top number, right? What is the top number? Mass. What is the bottom number? Charge. If it is a 1 or greater, it's the number of protons. So the top number is mass. So what is their mass? 1U. Number 4, which statement describes the relationship between two electrons in an atom of magnesium in the ground state? Okay, so I can see that it's talking about first shell, second shell, first shell, second shell, and I can see it's talking about same or greater. I see third shell mentioned. All right, so let's just briefly go over that. Here we have a nucleus, and then we have energy levels or shells with electrons in them. So this would be first energy level, second energy level, third energy level, or first shell, second shell, third shell. When do I get more energy? The further away from the nucleus I go. So, does the electron in the first shell have the same energy as the second shell? No, because the second shell is further away. Does an electron in the first shell have a greater energy than the second shell? No, because it's the second shell that's further away. An electron in the second shell has the same energy as electron in the third shell? No, because the third shell is further away. Well, this one better be right. An electron in the third shell has a greater energy than the second shell. Yep, you bet, sure does. All right, number 5. As an atom in the ground state changes to an atom in an excited state, the atom what? Well, here's what's important to remember for these two choices that I'm going to cross out right now. The atom doesn't change in the number of particles it has. Also, mass number are the particles in the nucleus, and those are never lost or gained in terms of going from ground state to excited state, so that's not changing. In fact, the number of electrons doesn't change. But in excited state, so here we have our atom again, nucleus, energy level, energy level, energy level. That electron, right, will move up to a higher energy level to get to an excited state. So that means it must be absorbing energy. Number 6, which statement describes a chemical property of copper? So a chemical property is something where I have to try and force it into a chemical reaction in order to identify it. So copper has a red-orange color? Nope. Copper can be flattened into sheets? Nope, that's malleable. Copper reacts, oh, look at that keyword, react, 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 react. That's a chemical property, okay? And copper conducting electrical current is just another physical property. Number 7, at STP, 2 forms of solid carbon, diamond and graphite, have different properties because. Why do they have different properties? Why does anything ever have different properties? Because they have a different structure. Different properties result from different structures. Period. End of story. Always the answer. Okay? Number 8, which element in period 2 has the highest first ionization energy? Okay, so now I need a reference table, right? So let's go to our reference table. And it says which element in period 2. Okay, so here's period 2. Let's look up the first 3. So Li, Be, and B. So I still need the reference table. So I'm going to go Li. All right, so here we go. We start here. Here's where period 2 starts. And where does period 2 end? It starts with lithium and ends with neon. So from lithium to neon. So this is all period 2. Okay, so if I go back to the question, has the highest first ionization energy. So first ionization energy right here is this column. So I'm looking at these numbers, right? Which one is the highest? Well, it's obviously this one. And there it is, neon. Number 9, which phrase describes a specific compound? Okay, so remember matter is either a pure substance, right, or a mixture. If it's a pure substance, it's either an element or a compound. If it's a mixture, it's either heterogeneous or homogeneous. So what is a compound? Well, a compound does not contain only one element. A compound contains 2 or more elements, right? Can a compound be separated physically? Nope, that's a mixture. All right, is it composed of elements chemically combined in a definite ratio, or is it composed of elements mixed in proportions that can vary? Chemically combined in a definite ratio. This, number 4, is the definition for a mixture. They are mixed in proportions that can vary. You can have it saltier or sweeter, or you can have more of something. In a mixture, the proportions can change. In a compound, there's always a definite ratio. What does that mean? That means H2O, which is water, is always 2 hydrogens and 1 oxygen 100% of the time. Okay? All right, we're on to question 10. Which type of chemical formula shows the arrangement of the atoms in a molecule? So, for example, which one would show that water, right, looks like this, right? Or that ethane looks like this. So what kind of formula shows that? The arrangements? Yeah. It's structural formula. That's the one that shows the arrangement. Okay. Empirical is the reduced to lowest terms. Molecular shows you exactly which atoms are in the molecule, but not how they're connected, how they're arranged. Okay. Number 11, a 2.50 liter sample of SO2 gas at STP and a 2.5 liter sample of CO2 gas at STP can be differentiated by comparing their. Okay, well, let's see. Liters measures what? Volume. Well, they have the same volume. STP, right? Standard temperature. So that's 273 Kelvin or 0 degrees Celsius. What is phases? Phases mean states of matter. So look at them. They're the same. So what can they be differentiated by? Their masses, because they're made up of different elements and different amounts of those elements. Number 12, which terms identify the two major categories of compounds? Well, it is ionic and covalent, but I don't see that as an option. So there is another term that I can use for covalent, and that is molecular. So ionic and molecular, or ionic and covalent. So the one that we see here is ionic and molecular. Number 13, which molecule of an atom contains a multiple covalent bond? Okay, this will be helpful if you don't remember it off the top of your head to look at the reference table. Okay, so when I look at the reference table, I'm going to go to the periodic table and I'm going to look for these elements and find their valence electrons. Okay, so bromine has 7 valence electrons. Chlorine, which is in the same group, also has 7. Hydrogen has 1, and oxygen has 6. Okay. Why does that matter? So if I'm bonding a hydrogen to a hydrogen, right? And each hydrogen only has 1 valence electron, I only need 1 bond to pair those up. And so bromine and fluorine both have 7 valence electrons. So I can tell you they're not going to be the answer because they would follow the same pattern. But let's see why. When I put 7 valence electrons around fluorine, I see 1 unpaired. That is very like hydrogen, which has 1 unpaired. So it will just bond like this to another fluorine with just 1 bond because we have 1 unpaired electron. If we look at oxygen with 6 valence electrons, it has 2 unpaired. So when oxygen bonds to oxygen, it has to look like that. So there we go. Number 14, which molecule is symmetrical in both shape and distribution of charge? So this means we are looking for something non-polar. So the atoms are arranged equally around a central atom typically, and that means the charge is distributed evenly. This HCl, I've got Cl on this side and H on this side. That can't literally be even. Here I drew what water looked like. That is not an even distribution of charge. So now between these two, which one has an even distribution of charge and it is symmetrical in shape? It is methane. Okay, ammonia is polar. Number 15, what occurs when 2 atoms of bromine react to form a molecule? Now, you should understand, first of all, that means a bond is formed. So we can automatically get to a 50-50 here, right? Because we know that a bond is formed. Now, what you have to remember is this, that when you try to break something, you have to put energy in. That means energy is absorbed. So when you form a bond, energy is released, okay? Number 16, atoms of which element have the strongest attraction for electrons in a chemical bond? Well, I know this answer without looking up anything, just because I know kind of the fact about it, but let's look up electronegativity. So here's electronegativity, and what are we looking for? Fluorine, nitrogen. Okay, so electronegativity, fluorine, nitrogen, what else? Phosphorus and potassium. Okay, so we have phosphorus and potassium. So which one has the highest electronegativity? Yeah, it's fluorine. How do I remember it? Because literally the symbol for fluorine is F. That's like the worst grade you could get, but it's the strongest electronegativity. Chlorine has the perfect electronegativity.